projectiles, and the path of a projectile is parabola, and as well as the parameters of projectile. Means whenever the body is traveling in a plane, then it is projected with an angle or some of the angle theta with the horizontal, then the path will be, the trajectory is a parabola. In that case, we can get the values. The parameters are maximum height, time of flight, and a horizontal range, and a time of ascent we can measure from that trajectory. So that's why we can get that the parameters of projectiles are maximum height, time of ascent, time of flight, and a horizontal range. So in that case of already we derived an equations for that also in the earlier video. Now maximum range. What is meant by the maximum range? Whenever that body is projected, means either if the body is projected with an angle with the horizontal and reach to the with the velocity, with this velocity that body can move certain distance, that can't go more than that distance. With that velocity, that body cannot go more than that distance. Horizontal distance is called as R maximum. That is called maximum range. And at what angle, if the body is projected with some velocity, at what angle if the some of the velocity is there, whenever we projected that body with some angle, at a certain angle if we project that body with velocity, then the body can go to the forward, means maximum distance. That is the maximum range. The maximum range. Whenever that the body is traveled certain distance, that it depends on this angle of theta. For example, if a body we projected like this and like this, then whenever it is making an angle theta with the horizontal, theta will depend. The maximum range is depends on that angle also. Because of that's why that is R is equal to U square sin 2 theta by G. Means this angle also and velocity and angle is also depends, the range will depends on that. Whenever this is R becomes maximum when the sin 2 theta is equal to 1. Sin 2 theta is equal to 1 means here whenever the range is U square sin 2 theta by G. In this case of if we, the sin theta is equal to 1. 1 will be the maximum. So then only 2 theta is equal to sin inverse of 1. Then from that equation 2 theta is equal to 90 degrees. We know that because of sin 90 is equal to sin 90 degrees is equal to 1. Then in case of sin inverse of sin 90, then we can get that 2 theta is equal to 90 degrees. Then from that equation theta is equal to 45 degrees. If the body is projected with the angle of 45 degrees, then only the range will be maximum within that velocity. Means the angle, the range becomes maximum when the angle of projection is theta is equal to 45 degrees. Let's see what is the equation for the maximum range. Here we know the formula for range is R is equal to U square sin 2 theta by G. That is the equation for the horizontal range. So in this case of, if in case of theta is equal to 45 degrees, if we substitute that value, then U square sin 2 into 45 will be sin 90 by G. Then from that equation the range, horizontal range, maximum range is R is equal to U square by G. Means here whenever the body is projected with velocity at an angle of theta is equal to 45 degrees, then the body reach to maximum range. By this equation we can find it out that maximum range. Whenever, once again, if the body projected with some certain angle theta is equal to 45 degrees, then the body reach to its maximum range. Maximum range at an angle of theta is equal to 45 degrees. We should remember that one. So from that R is equal to U square sin 2 theta by G, that is equal to U square sin 2 into 45 degrees. By substituting this value, by calculating that, then we can get R maximum is equal to U square by G. This is about a maximum range. This is a maximum range. That is a R maximum. So another point. These are the important points to know about for the calculation purpose and for the 2 marks questions also. These points are very, very important. So another one is that horizontal range depends on the angle. If we project the body with two different angles with the horizontal, then can we get the same range? Yes, we can get the same range whenever we project it with different angles also, then we can get the same range with the velocity. Here, with an angle of, the angles of projection for some range, for the angles of theta and 90 minus theta, means two angles of projection for same range. Same range means here a body is projected with an angle of theta and reached to some of the distance, that is a range R. Range R. And also another thing, another body is also projected with the another angle and reached to the same point. Means what is the difference between them? Means this is the higher angle and this is the lower angle. Lower angle will be the theta. Theta, and this will be the, this theta is also making an angle with the vertical, and this angle, higher angle means higher is making an angle theta with the vertical, and the same angle made by the horizontal also. This horizontal theta and this vertical theta both will be the same. Both are same. So that's why we can get that this is theta, and whenever if we take this angle, this is total 90 degrees and this will be theta, means 90 minus theta. 90 minus theta. This 45 degrees angle will be the maximum range. Means by the projecting the body with two different angles, can the body reach the same range? Yes, that body can reach the same range with whenever the body is projected with two different angles. The different angles also must be theta and 90 minus theta. The theta and 90 minus theta. And as well as here the range is same. Here the range is same, but their trajectory is different. Their trajectory is different. These ranges are same, but the trajectory, the lower trajectory will be like this, and upper trajectory, higher trajectory will be like this. The trajectories are different, but the range is same. Even though range is same, the trajectories are different. The trajectories are different. So the higher is making a higher trajectory is making an angle theta with the vertical. The same angle made by the lower with the horizontal. Once again, the higher is making an angle theta with the vertical, and same the angle theta is made by the horizontal with the lower trajectory. So that's why we can say that whenever for the say two angles of projection for the same range, for the angles of theta and 90 minus theta, if the body is projected with a theta angle and 90 minus theta angle with the horizontal, then the range will be same, but their trajectories are different. And one more thing is the higher trajectory is making an angle vertical with the vertical is equal to the angle made by the lower trajectory with the horizontal is also same. So that's why is their higher and lower trajectories make equal angles with the vertical and horizontal axis. These are the one of the important point for the 2 marks question and also for the objective purpose also. Then next the topic is instantaneous velocity. We know that what is instantaneous velocity. In earlier videos we discussed about that what is instantaneous velocity, and by discussing about the velocity also, how is average velocity and instantaneous velocity is different from one another also we discussed. In that case, instantaneous velocity means when the body is moving in motion, then the velocity of an object, the velocity of a particle or of an object at a particular instant of time, is called instantaneous velocity. When the body is moving in the direction is a parabola, the trajectory is a parabola, then the body has reached at point B, the velocity will be acting in this direction. By taking these components, that is a vertical component is Vy and horizontal component is Vx. At angle of beta will be the angle, the direction will be take, the angle will be thus. Here the vertical component of velocity, if we take that, we know that vertical component will be, the body is projected vertically, so that's why we can consider that u sin theta, and this will be u cos theta, horizontal component. By taking this after t time, then by taking this v is equal to u plus at formula is there for the kinematical equations of motion. From that equation u, we know that the initial velocity, that is u sin theta. So we are substituting this v is equal to u sin theta, and a is equal to, the body is moving vertically upward, so that's why for the vertical, here we take in the vertical, so that's why the acceleration due to gravity is a minus g. So from this equation Vy means a vertical velocity is equal to vertical component of velocity after time t, that is u sin theta minus gt, u sin theta minus gt. And whenever that, by taking the horizontal velocity will be constant, we know that. So here horizontal component of velocity will be Vx is equal to u cos theta, normally it's a constant. So from that equation means when the body is projected, the trajectory is a parabola. After reaching certain point, the vertical components will be Vy and horizontal component will be Vx. By taking this one, here v is equal to u plus at formula. From that equation we can get that by taking the vertical, the velocity will be u sin theta, because of it is making an angle theta with the horizontal. So vertical velocity will be Vy, vertical component, u means u sin theta. Here acceleration due to gravity will be minus g into t after time t, then we write that one. Then horizontal component of velocity is constant, we know that. From that Vx is equal to u cos theta, Vx is equal to u cos theta. So from that equation, by substitute, to find out the resultant magnitude of this one, then we can do this. This is the resultant, we can find the magnitude of resultant, that is v is equal to root of vx square plus vy square. Vx square plus vy square means the sum of square root of sum of two horizontal and vertical components, then we can get the resultant velocity, magnitude of resultant velocity from that equation. Then we know that vx is equal to u cos theta, so that's why u square cos square theta plus Vy means, already we find out that vertical component after time t, Vy is equal to u sin theta minus gt, u sin theta minus gt. So u square u sin theta minus gt whole square, u sin theta minus gt whole square. From that equation v is equal to root of, by calculating this is in type of the same as a minus b whole square formula, by expanding that like a minus b whole square formula, then we can get that here u square cos square theta plus u square sin square theta plus gt square minus 2u gt sin theta. From that, here u square are same, by taking common, then we can get that u square of cos square theta plus sin square theta. From that, cos square theta plus sin square theta is equal to 1. So from that equation we can get v is equal to root of u square plus gt square minus 2u gt sin theta. This is the magnitude of the resultant of velocity, instantaneous velocity. Then we can get that the direction of the velocity of the trajectory is a tangential. This is a tangential. The direction of the velocity of a trajectory is a tangential. Here is also tangential, and this one is also tangential to the path. So that's why here that instant the angle of trajectory will be theta. This is a angle theta, beta. The angle the trajectory or velocity makes with the horizontal is a beta. That is this one is the beta angle. So that's why beta is equal to, we know that the tan beta is equal to opposite by adjacent. Opposite will be here Vy and adjacent will be Vx. So that's why we are writing the tan inverse of V by Vx, that is equal to tan inverse of, we know that Vy is equal to u sin theta minus gt by u cos theta. Vx is equal to u cos theta. This is about instantaneous velocity.